Okay, worksheet 7, inequalities. So if we got a funky inequality and you're thinking, uh-oh, these are where we need our number lines. And you're going to do number lines a lot next year in calculus. So number lines come up a lot. They're going to be a big deal. So when we have a situation like this, instead of being equal to 0, because normally you'd say, oh, this is simple. X is equal to 1, X is equal to -3. That's when it's equal to 0. But now I've got an inequality, which means there's actually potentially an infinite number of answers. So I got to figure out, okay, what set of answers? Well, this is where we go to the old number line. And we're going to say, okay, we're going to put our zeros on the number line. So -3 and 1 are our zeros. Then we're going to say, okay, open or close circles. Is the -3 included? Is the 1 included? Well, since it's or equal to, close circles because they are included. Now for the fun part. We need to do some test points to see what works. So if you can test 0, I always recommend testing 0. So if I plug 0 into the original function, I would get -1 plus 3, and I don't even care what the actual numbers are. I just care what this, is it positive or negative? Because a negative times a positive is negative. So that entire interval right there is going to be negative. If I plug in something like 10 and somebody says, why don't you just 2, I always plug in something really big. So it's just easier to check. Because if I plug 10 in here, no doubt about it, that's a positive times a positive. Positive times a positive is positive. Down here, I'm going to plug in -10. So if I plug -10 in there, -11, -7. So no doubt about it, negative times negative is still positive. So which set of answers do I want? Well, I want to be less than or equal to 0. So I want the negatives. So I want from -3 to 1. I want the negatives. Oh no, close circles. So brackets. So you are going to have to be very careful to write very neatly. Write very neatly so I can tell the difference between a bracket and a parentheses, because that's going to make a big difference. And you'll see in a second. Uh-oh, this one looks kind of stupid. I'm going to factor out the negative. So if I factor out the negative, so now I have x squared minus 9x plus 20 is less than or equal to 0. Somebody says, why don't you move the negative to the other side? Remember, if you move the negative to the other side, you have to flip your zero, you have to flip your inequality. So you can do that if you want. I personally don't care. So what do we get here? -5 minus 4 is greater than 0. So our zeros are 5 and 4. So we go to the number line. We go to the number line and we say, okay, my zeros are 4 and 5. It's greater than or equal to, so these can both be closed circles. Let's start doing some tests. So I always recommend, if you can, test 0. So if I would go to this row right here, plug 0 in here. So it's got a negative in front. 0 minus 5 is -5, 0 minus 4. So negative, negative, odd number of negatives stays negative. So somebody says, okay, well, this is stupid. I'm going to do 4.5. So it's still got the negative in front. So negative in front. So negative in front, and then 4.5 minus 5. Oh, that's negative. 4.5 minus 4 is positive. So negative, negative, even number of negatives is positive. Then come out here and do something like 10, still has a negative in front. 10 minus 5 is positive. 10 minus 4 is positive. One negative, odd number of negatives is negative. So what do we have here? I'm supposed to get the greater than 0. I'm supposed to be greater than, aka positive. So I'm the positives. I'm between 4 and 5. That's a bummer. I didn't do anything with an infinity. Don't worry, we'll do an infinity in a minute. They're both closed circles, so we would say, okay, got to do the brackets. Okay. All right, let's make it a little bit more complicated. What if I have a rational function like this? So a rational function, we still go about it the same way. You're going to say, uh-oh, I still need the zeros. X is equal to 1, X is equal to -3. What makes it go to 0? What are the zeros of the, and I know you're going to yell at me in a second, but don't worry, we're going to answer the question some of y'all have. Okay. Open or close circles. If X is equal to 1, I get 0 over 4 which is equal to 0. Okay, it can be equal. It's okay for a fraction to have 0 in the numerator. So 1 can be a closed circle. But if I plug -3 in here, I get 0 in the denominator. A fraction can never have 0 in the denominator. So even though it says or equal, the 0 in the denominator is always an open circle. 0 in the denominator is always an open circle. So once again, we go to the test points. So you're going to say, all right, 0 is a good test point. Now check this out. I got to plug into here. So 0 minus 1 is negative. 0 plus 3 is positive. Negative over positive, just like when we're doing multiplication, an odd number of negatives. If I do something like this, 10. If I plug 10 in there, 9 over 12. Point is, it's positive over positive. If I do -10, negative 10, that's going to be -11 over -7, whatever, negative over negative, even number of negatives is positive. Which ones do we want in this case? We want the greater than, the positives. Oh, so it's way the heck out here, all the way to -infinity, to -3. There's a gap in here. So we got to stop here. Since it's open circle, we do parentheses, and you have to write it very neatly so that I know you mean parentheses. And we start again at 1, and it's closed circle, so bracket all the way to infinity. So be sure to write neatly so I can tell the difference between your bracket and your parentheses. All right, you get to this problem right here, and you're like, looks like we're going to have to do some factoring. So what do we have here? X minus 8, X minus 3, X minus 5, X plus 5. So I got a bad feeling. This thing has 4 zeros. This thing has 4 zeros that we need to graph. So here we go. We got 4 zeros we need to graph. So this one's going to be a bit of a hassle. So who's the furthest? So -5, 3, 5, 8. Let me see. It's or equal to. So the numerator can be closed circles. The numbers in the denominator have to be open circles, because the denominator can't be 0. Okay, let's start doing test points. So if I plug in 0, that's going to be a negative, 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 positive. If I plug in 0, negative, 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 positive. 3 negatives make a negative. If I plug in 4, that would be a negative, positive, negative, positive. So 2 negatives is a positive. If I plug in 6, that would be a negative, positive, positive, positive. So 1 negative. If I plug in 10, they're all positive. Out here, if I plug in -10, that would be a negative, a negative, a negative, and a negative. 4 negatives make a positive. So which answers do we want this time? We want the less than, we want the negatives. So -5 to 3 union 5 to 8. -5 is an open circle, so parentheses. 3 is a closed circle. +5 is an open parentheses. 8 is a closed circle, like that. So a little bit funkier. All right, I'm going to stop this, and we're going to have to do a separate video for the next type of problem because they're a little bit more complicated.